Now we're going to do some practice naming alkanes in this video. So some practice with IUPAC nomenclature of straight and branch chain alkanes. So what's the main thing we need to do? Well, we first look for a parent chain, and we're going to count the longest continuous parent chain. So this first structure, we've got just a straight chain alkane. We've got C with 3 H's, then C with 2 H's, C with 2 H's, C with 2 H's, C with 2 H's, and finally C with 3 H's. So we've got 1, 2, 3, 4, 5, 6 in that main parent chain. If we've got 6 carbons in our main parent chain, we need our prefix for 6, which was hex. It's got all CC single bonds, so that's going to be hexane. Let's look at the next one. We've got CH3, CH2, CH2. Then it goes up like a stair step straight to another CH2, and then over to the right like a stair step CH2, and then up to CH3. Now, don't let this staircase or zigzag of the chain fool you, because this is just 1, 2, 3, 4, 5, 6 carbons right in a row. This is still hex and it's still hexane. So this is just another form of hexane, just drawn a little differently. Okay, now let's try the next one. It's CH3, CH2, CH2, a C. Coming down from that C is a CH3. Coming up from it is CH2, and then connected to that is CH3. Now, going back to the C before it had the branches, to the right of it is CH2 and CH3. So in our longest chain, it looks like we have 1, 2, 3, 4, 5, 6 carbons. Now we can try other chains. Let's try going up this time. Let's try 1, 2, 3, 4, 5, 6. That's still 6 for our longest chain. So it looks like no matter what we try, we're only going to have 6 carbons in our longest continuous carbon chain. So that makes our 6 carbon chain our parent chain. Now we want to number it so these groups coming off of this carbon have the lowest possible numbers. So we could try either 1, 2, 3, 4, 5, 6, numbering left to right. Here the groups are on carbon 4. Or we could number right to left and go 1, 2, 3, 4, 5, 6. Now, in the numbering from right to left, the groups actually have the lower number 3. So in this case, it's better to give them the lower number 3. Now, the CH3 coming off the chain on the third carbon going down is just a singular CH3. So our prefix for that is meth, and then we do YL for a group. Now, coming up at the third carbon is CH2CH3. That's actually a 2-carbon group. Our 2-carbon prefix will be F, and then a YL for group. So that'll be our ethyl group. So it's getting a little messy. Maybe just to clarify, we'll clean this up. We'll go 1, 2, 3, 4, 5, 6. So there's our parent chain. Here's a methyl down here on the 3. Here's a methyl going up from the 3, or ethyl rather. So ethyl up from the 3, methyl down from the 3. Now, the last thing we need to do is alphabetize these groups so that the groups get the lowest, number order by alphabetizing. So we actually need to put ethyl before methyl. So we need to do 3-ethyl and then a dash and a 3 and methyl. And then our main parent chain has 6 carbons, so that will be hexane. So 3-ethyl, 3-methyl hexane. And why did we do that? Well, ethyl comes before methyl, and we need to be sure to alphabetize the groups. So the groups go in alpha order. Let's try a couple more examples. In this example, we've got CH3 and then C with a CH3 going down and a CH3 going up from it. And then we continue to the right to CH2 and then to CH with a CH3 going up and then CH3 to the right. So that main parent chain looks like it's 1, 2, 3, 4, 5 carbons. Then it looks like it has on carbon 2 a methyl up and a methyl down, and it looks like on carbon 4 a methyl up. Now we could number left to right and go 1, 2, 2 for those methyls, 3, 4 for another methyl, and 5. So in this numbering left to right, we have 2, 2, and 4 for the methyls. If we numbered right to left, we would have 1, 2. We'd have one methyl at carbon 2, and then we'd have 3, and we'd have 4, 4. We'd have 2 methyls at carbon 4. So if we numbered in the opposite direction, we'd have 2, 4, 4. Now we want the groups to have the lowest overall numbers. So we're going to stick with the 2, 2, 4. And now because there are 3 of the methyl groups, we need to call it trimethyl. And then there were 5 carbons in the parent chain. So pent, and then, pent, and then all single bonds, ane. So 2, 2, 4 trimethylpentane. Let's try the next example. Let's see. We've got 1, 2, 3, 4, 5 carbons. Look, there's a methyl coming down and up off carbon 2 and a methyl off carbon 4. Wait a second, this is the exact same structure, just drawn out a little differently. So this is also 2, 2, 4 trimethyl and then pentane. So those two happen to be the same. Okay, let's look at this next one. Now remember that every point is a C. Sometimes it helps to draw them in. 1, 2, 3, 4, 5, 6 C's in a row. Looks like it's hexane as our parent chain. Now there's a methyl group here and here. There's a methyl group at carbon 2 and one coming off of carbon 3. And I'm pretty sure they should be 2 and 3, but let's check. 1, 2 for that second methyl group, 3, 4, 5, 6 is my numbering from the left. If I number from the right, the groups will be at 1, 2, 3, 4, 5, 6. So numbering left to right, the groups were 4 and 6. Numbering, right to left, they were 4 and 6. Right to left, the groups were 4 and 6. Left to right, the groups were 2 and 3. And so 2 and 3 wins over 4 and 6. We want the lowest possible groups. So this one's going to be 2, 3 dash di because there's 2 of the methyls, dimethylhexane. 2, 3 dimethylhexane. Now the last thing we have here is a little pentagon. A pentagon's a ring, and rings we're going to call cyclo because there are 1, 2, 3, 4, 5 carbons. We're going to call it cyclopent. Like I said, it looks like a pentagon, and ane because they're all single bonds. So cyclo is going to be for our rings. That really indicates that there is a ring. So 5 carbons in a ring would be cyclopentane.